Hello guys, welcome back to my channel. So today we will continue with Eigrp routing, and if you didn't check the previous videos how to enable Eigrp, please check my check those videos. But today we're gonna see how we can manipulate routes. Like if we have actually Eigrp configured on our router 1, router 2, and router 5. Now we're going to configure Eigrp on router 3 and 4 and see how we could manipulate the route, that the traffic, the route that goes from R2 to R3, instead of going directly to R3, how we can push them out through R7. Okay, so if I go into R2 and R3, I'll see that R2 is already configured. Let's go into R2. Show IP brief. So R2, the interface is already configured, and also the routing is configured. If I do show IP route Eigrp, okay. So R2 is having Eigrp routes from R1, okay, and R5, okay. And the reason is because we have Eigrp configured. So run. Okay, so we have Eigrp configured. The only thing we have to add here is that we set R2, only this interface is going to participate in Eigrp. So we have to add gig 02 and gig 01. That way we're going to be able to receive routes from R7 and from R3. Okay, so we're going to the router mode. We're going to say no passive interface gig 02 and gig 01. Because any interface if it's passive interface default, it means that it's not going to participate in Eigrp routing because it doesn't receive unicast and multicast Eigrp. So we're going to say no passive interface gig 01. Okay, no passive interface gig 02. Okay, now if I save, I should still not see routes from R3 because R3 and R7 because those routers are not yet configured. If I just show IP route Eigrp, okay, I'm not able to see routes. I have to go into those two routers and enable Eigrp. Okay, so let's check first on R3. So on R3, we already have the interface configured exactly how here. So I show IP interface brief. Okay, we already have the loopback interface configured with the router ID here, and then the interface that connect R3 and the neighbors. Okay, so all that is configured. What's left on R3 on R3 to configure is the routing. So what I'm going to do right now, I'm going to use, previously we configured routing using numbers, okay, like we're using AS200 as our AS150, okay, that's the autonomous system that we're using on R2 and R1. So now I'm going to use a different method. I'm going to use a named access list, named routing configuration. So which means I'm going to go into configure terminal. I'm going to say router Eigrp. I'm going to give a name. Let's say the name is I'm going to call the name COP3. Okay, so I'm going to call it COP3. Okay, the name is locally significant. As I said, the router represents maybe a company, a new company, or a new office or new agency that's part of the organization. So I can call it COP3, that's the router name. And then I'm going to say address family IP version. Okay, if I say question mark, we have two possibilities, either IP version 4 or IP version 6. So I'm going to use IP version 4. And then I'll say autonomous system. I'm going to give the same autonomous system. This one is not locally significant. It has to match. Okay, so we gave 150 on the, give autonomous system 150 on router 2 and router 1. So if you want this one to participate, it's going to have the same AS number. Okay, say enter. And then we have to give the network, what are the networks that are going to participate in Eigrp. We're going to say all network. Okay, so we're going to say all. Okay, so all networks attached to this router 3 are going to participate in Eigrp. And then what else? Yeah, and that's it. And that's it for this one. So if I go out, let's save. So it should show IP route Eigrp. Okay. All right, so I figured out why we didn't receive Eigrp routes on router 3, because on this router 2, which is a directly connected, we didn't enable, we didn't have this route, the subnet advertised. Okay, if you check, so the interface is participating in Eigrp, but the subnet itself is not participating. We're going to have to do the same thing on this other interface. Okay, so the interface is participating in Eigrp, but the subnet does not participate. So I have to manually add it on router R2. So I'm going to go into router R2. And by the way, you can just double check, compare the difference between a named routing configuration and the numbered routing configuration. Okay, so if I do show run, okay, on the router 3, I want to check what's the routing configuration. So this is a difference here. Okay, so here is not named. Okay, instead of 150, I just say COP3. So this one is numbered, but here on router 3, I also have to specify the AS number. Otherwise, it's not going to be able to participate with Eigrp with the neighbors. Okay, so that's the difference. It's huge, but usually in real life, in companies, they basically prefer the named access list, because that way you can have several instances of autonomous system on the same router name. Okay, so anyways, with that, let me just add the subnet for R2 and for gig 01 and gig 02. Okay, and R2. So I'm gonna go to router mode, router Eigrp 150. So I'm gonna say network. I want this network to participate. It's going to be 192.168.223.0 and 27.0. So 192.168.23.0. Okay, once I do that, you're going to see router 3 is going to basically start receiving those routes. I'm going to do the same thing for router pointing to router 7, which is 27.0. Okay, so go out of there and save. Now if I go into R3, I do show IP route Eigrp. Okay, now I should start receiving routes from router 2, router 1, and router 5. Why? If we go in here, so we enable Eigrp here. Now we can receive routes from Eigrp routes from router 2, router 1, and router 5. Why? Because all routes learned by R2 are going to be shared to R3. So we know that before enabling ERGRP here, this router 2 already knew about routes from router 1 and router 5. That's why it shares it with router 3, since they have the same autonomous system. So now it's enabled on router 3. I have to enable ERGRP as well on router 7. Okay. So I'm going to go into router 7. And again, it's going to be named access, named ERGRP configuration. So router 7, the interface is already configured. If I do show IP interface brief, so the interfaces are already there. Just compare. So router 7, this is what we have here for router 7. So we have the loopback interfaces. Okay, they're there. Router ID is there, and then the interface is connecting router 7 to its neighbors. They're all up. So all I need to do on router 7 is just to enable ERGRP. Okay, I'm going to go to router 7 and say terminal router ERGRP. Let me call this one COP 7. COP 7. Okay, now I'm going to say address family IP version 4. Okay, and then I say autonomous system 150. Okay, it has to be 150. It has to be match on has to match. Then I'm going to advertise all networks attached to router 7, which is 0.0.0.0. Okay, and that's basically it. I'm going to save. I'm going to save, and then I'm going to I'll save. Now on router 7, I should be able to see routes coming from routers 3, 2, 1, and 5. Okay, let's check that out. Show IP route ERGRP. Okay, so now you can see routes coming from everywhere. Okay, so these are routes coming from router 3. Okay, from router 5 right here, from router 1. Okay, and from router 2. Okay, so we have routes. So we have a full mesh. Now, based on that, if we look at this diagram, we see that the bandwidth here is supposed to be 256. Bandwidth linking R2 and R3 to 256 meg. The linking R2 and R7 is 1544 meg. R3, R7 and R3 1544 meg. Okay, but actually this is like designated bandwidth. It's not the one that is by default. So let's see because we have to manually configure this bandwidth. Okay, these are just, I designated them. So we're going to basically manipulate this route to see what happens if we actually manually add those bandwidth. But in the meantime, let's check what we have by default. Let's go to R3. If I go to R3, let's see what routes, how R3 is learning those routes. I'm going to R3. So if I do show IP ERGRP topology, okay. So show IP ERGRP topology should give the routes, all the routes that are learned by R3, okay. So it doesn't distinguish, it gives everything that learned from its neighbors. So if I do this, enter, so it's going to show both the feasible routes and the feasible successful routes, okay. So no, sorry, the successor routes and the feasible successor routes, okay. So we're going to see this one. If you see only one route, it means that it's just the successor route, okay. We don't have like two other ways to get into to go to this network, okay. So we have just one way through gig 01, okay. That's what that means. So we'll go a little bit further. Okay. So we're going to have in some instances where we have two routes like this one. Okay. So this one says we are sitting on R3. If you want to go to this network, okay, there are two ways. There's the successor route, which is this one, and there's the feasible successor route. So how do you know the difference? The difference is in the sorry guys, that was not correct. We have here two successors. So I was trying to figure out which one has the bigger administrative distance. So basically, they have the same administrative distance, or the same metric. So there are two successors. Okay, so this is not a good example. We're going to have to scroll down a little bit more. Right, so let me make this very clear. What happened is I went ahead and actually manually configured the bandwidth. Okay, manually configured the bandwidth on R2 gig 01 to 256 and R3 gig 01 to 256. And then the same thing here on R2 gig 02, I configured 1544 and R7 gig 01, 1544, the same thing here. So let's just double check what I configured. If I go into R2, show run interface gig 01, okay. So I manually configured 256, okay. And on the gig 01, gig 02, configured 1544. And in the same way, I did those configurations on the other routers. Let's check R7. So on interface, what did I put? The interface gig 00 and 01. Okay, gig 0/1. Okay, so 1555, and the same thing for gig 01, gig 00. Sorry. All right. So in the same way, that's how I configured it. Now, with that in mind, having configured that, then we're able to check exactly what we were looking for, okay? Because previously I said we wanted to see what are the routes that are actually best routes, okay? What are the best Eigrp routes that are put on the routing table? So for that, we do show IP Eigrp topology, okay? If I do enter, now we're going to see, we're going to take any route here, okay? Let's take this one. How does R3 know about this route? Okay, he knows about it through via gig 02 and gig 01. Okay, so that's how he knows about this route. Now, among these two routes, there's just one successor route. Okay, the other one is a feasible successor. So this is a successor route, which is always the first, and the second one will be the feasible successor. And the first one is successful because it has a lower metric. Okay, so this number is lower than this one. Okay, that's the most important. This number is lower than this one. So this is going to be the successful route, and this is going to be feasible successor. So if you go into the real routing table, the global routing table, we're going to see only one route. We're going to see only this one. We're not going to see this one. Okay, and same thing goes for this one. See, how does R3 know about this route? He knows about it through two means, either going out through coming from gig 02 of R3 or coming from gig 01 of R3. Okay, and now this one has a better metric, so it's going to be the successor route. Okay, so just for, if I do this, okay, if I come here and I do, just to prove that that's the best route that is added on the routing table, if I do show IP route Eigrp, Eigrp, and then I pipe, if I pipe this one, okay, shows like this, maybe I do sections. Okay, so it says to get in to go to this network, you have to go out. It has to, it knows about that network from this interface. Okay, gig 02. So if you go back there, you go back here. Okay, this was here. I think it was this one. Which one is that? Okay, this one. Okay, so we said this was a successful route. Okay, so this one was not going to be on the global routing table, and that's what we have here. So this, when you do show IP route, EIGRP, you basically see the best routes. Okay, if you do show IP IP EIGRP topology, you see all the routes, both the successful routes and the feasible successfor routes. Okay, so that's what I wanted to show you here. So all right, so next thing is if we do show IP, we're still on R3. If I do show IP route EIGRP, okay, we're going to see all the routes are coming out. Are learned through gig 02, okay, of R3. So you see, it's all those routes are learned through gig 02 of R3. So if we're going to this diagram, see all the routes are coming in through this interface. Okay, and the reason is because it has a beta bandwidth. Okay, so it's this link is too slow. The beta goes out through this link. Okay, so we have the impression this link is not used. Okay, so what we're going to do right now is we're going to say, okay, specific routes, we're going to allow them through this good link. Okay, but the less for this 2 gig 01, just to make sure it's in use, we're going to link the summarized routes, okay, coming out from R2. Okay, so this the summarized routes of the 172.70.17, the summarized routes are not going to go out through gig 02, they're going to go out through gig 01. Okay, because otherwise we will have everything going out through gig 02. Now it's like the gig 01 doesn't have any use. Okay, so that's what we have to do right now. All right, so we're going to go into R3 into R2, and then we're going to summarize that route. Okay, the route from this loopback interface, the 172.17.4, okay, .0, .5.0, .6.0, .7.0. Okay, so let's go into R2. So on previous videos, we've seen how how we can summarize those routes. Okay. Right. So we want to summarize just the first 2 octets. So the first 2 octets is going to be summarized. Okay. So it's going to be, we're going to create an access list. Terminal access list 1 permit. We're going to say we're going to permit 172.17.0.0. Okay. Just the first 2 octets. Then it's going to be the wildcard mask. Okay, the wildcard mask is going to be 0.0.255.255. Okay, that's what we're permitting. Now we'll create a route map. Route map. Let's call this one leak 2. Okay, let's say permit 1. Permit 1. Okay, that's the access list we're permitting. And then we say match IP address. I think I should. Okay. Match IP address 1. think I made an error there, but I have to see if it works. So I'm going to exit out of there, and then I'm going to say go into the interface configuration. I'm going to say interface interface gig01, okay, because we want to allow that traffic through interface gig01, interface gig0/1, okay. Let's say IP summary address Eigrp 150, and then I give the summarized address, which is 172.17.0.0, and then it's asking for the network mask, which is 0.0.255.255. Okay. No, network mask should be 255.255.0.0. Okay, let's see. Okay, all right. I forgot to add the statement for the route map. Okay. Okay. Now, if I do a question mark, it's going to ask me what's the leaked route. Okay, leak map, and I have to add the route map name that we gave, which is leak 2. Okay, and that's it. I'm going to exit out of there. I'm going to save, and then let's just double check what we configured. Say show run, show IP, show access list. Okay, access list is there. Show route map. Okay, route map is there. Okay, it's having some hits. So what we're going to do is we're going to go into R3 and see exactly what R3 is saying. So I have the impression I made an error in the configuration of the route map, but we're going to go to R3 and see exactly what's changed. So let's go into R3. So if you go into R3 and do show IP Eigrp topology, okay. Basically we're going to pipe 172.17.0, okay. 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 So basically I want to know how R3 is learning about the summarized routes. So let's see if it sees the summarized route here. Okay, right. We do have the summarized route right here. Okay, so this is the summarized route. So how does it know about it? It knows about the summarized route through gig01, okay? And it's the only successor route, which means we should see the summarized route through gig01 on the global routing table, okay? So we succeeded on that one. I actually thought I made an error. Maybe I made an error, but in any case, what I wanted to show is actually visible right here. You can see that the summarized route, instead of going out through gig01, gig02, that's all the other routes, is going out through gig01. Okay, so let's go to the global routing table. Let's say show IP route Eigrp. Okay, so everything else is going out to gig02 as intended, except the summarized route, which is awesome, excellent. Okay, you see everything else is going out through gig02. Okay, all the specific routes are going out to gig02, except the summarized route coming out from from router 2. Okay, so router 2 is that's the only route that we manually allowed going out to gig 01 from route 2. Okay, so that's excellent. That's what we wanted. That's the intention we set for. So that's it for this video. I didn't want to make it too long. I know it's been actually long, but I'm going to stop here. And then the next video, I'm going to make it a little bit different, but it's going to be the last video on this series. So the next video I want to do is I want to show how we can enable authentication between router 1 and router 2, router 1 and router 5 using name router configuration. Okay. So instead of using the numbered router configuration, I'm going to use the named router configuration and then allow authentication between R1 and R2. And secondly, I don't want R5 to participate in any other routing updates coming out from all the other routes. So I'm going to change the routing autonomous system here. And then I'm going to create a new autonomous system on router 1 that basically permits it only to authenticate only to R5. Okay, so that's going to be the for next video. And for this one, thanks so much for watching, and talk to you in the next video. Okay, thanks.